The inverse tan hyperbolic is equal to this, a half ln 1 plus x over 1 minus x. And we also need to find the domain. So we're going to start by writing y equals tan hyperbolic of x. And I'm going to be making x the subject to get the inverse function. But we're going to be getting it in terms of exponentials. Now, tan hyperbolic is sine hyperbolic x over cos hyperbolic x. And that then becomes a half e to the x minus e to the minus x over a half e to the x plus e to the minus x. We can cancel the halves out. You might just know that straight away, but anyway, this is what we get. And now, just like with cos hyperbolic and sine hyperbolic, the aim is to make x a subject. We're going to create a quadratic in terms of e to the x. So multiply through, we will get e to the xy plus e to the minus xy equaling e to the x minus e to the minus x. And then I'm going to times through by e to the x. So I'll get e to the x squared y. In fact, let me write y now as like the term on the left, so it's sort of the coefficient. And then that is going to be plus y. That is then going to equal e to the x squared minus 1. Okay, and I don't have any e to the x terms here, which you do get with cos and sine inverse hyperbolic when you're dealing with it. So let's get it. Right, it's going to be, let's factorize out the e to the x squared. So I'll have y minus 1 e to the x all squared equals minus y minus 1. Just going to bring this down because I'm running out of space. Right, now actually it makes sense to times through by minus 1. Let's make it 1 minus y e to the x squared equals y plus 1. So then e to the x squared equals y plus 1. Actually, I'm going to write it as 1 plus x. Oh, sorry, 1 plus y over 1 minus y. And you can see we've got this bit here. Square root, e to the x will be plus or minus the square root of 1 plus y over 1 minus y. But we're going to reject the negative. The left-hand side is always positive. And then x is going to equal ln root 1 plus y over 1 minus y, which we could rewrite. We could bring down the half because this is 1 plus y over 1 minus y all to the power of a half. So it's a half ln 1 plus y over 1 minus y. And therefore, inverse tan hyperbolic is precisely this, but with y replaced by x. Because I found the inverse basically to say this is, this is now my f inverse x, because that there originally was my f of x. Okay, just need the domain. So for this, the domain, sorry, not for this one, for tan hyperbolic, the domain is actually all real numbers. So we just need the range because then the range becomes the domain of the inverse. Now, as x gets really large, this function actually tends to 1 because these terms end up dominating and you get an asymptote. So the function, let me call it y, is always going to be less than 1. It can't go above 1. And when x is large but negative, then these terms end up dominating and it approaches minus 1. So that is the range for tan hyperbolic. I've only gone through that quite quickly, but it's something you should have seen in the past. And this becomes the domain for our inverse. 1 less than, so minus 1 less than x less than 1. It did say to specify k, so I'll just write down k equals 1. Right, now for part B, hence or otherwise, you typically want to use the hence here, solve this equation. Okay, so what I'm going to do is take the inverse tan hyperbolic of both sides. And then I'll get inverse tan hyperbolic 2x equals ln root 2 minus 3x. And now I can use this result here. So I will have a half ln, then it'll be 1 plus 2x over 1 minus 2x equaling ln root 2 minus 3x. But what I can do is bring that half back in to make it a square root. And then we can get rid of the lns, because you can imagine raising both sides of the power of e. We can just say, look, we're finding a ln of two functions. It must be that the argument is the same. And then it must also be, we can get rid of the square roots. So 1 plus 2x over 1 minus 2x must equal 2 minus 3x. All right, that's more like it. We're back into sort of territory of polynomials. Multiply through, so 1 plus 2x equals 2 minus 3x times 1 minus 2x. 2 minus 4x minus 3x plus 6x squared. Therefore, 6x squared, that gave me minus 7x, and I'm minusing the 2x. 6x squared minus 9x plus 1 is equal to 0. And just use your calculator for this. We get x equals 9 plus root 57. I think it doesn't ask for exact answers actually, but we'll do it, over 12, or 9 minus root 57 over 12. Now when you get solutions to this, remember we have technically squared. You should always check for spurious solutions. So let's work out what they are. They end up being 1.3791 and 0.1208. So you could put it back in and see if there's any problems. But remember, we did have this little condition earlier that x had to be between minus 1 and 1. So actually, in our case, we have to have that 2x is between minus 1 and 1. So x had to be between minus 0.5 and 0.5. And this one is not, so we're going to reject it. Therefore, our sole solution, written exactly, is 9 minus root 57 over 2. Well done. I've just realized one other thing I just want to briefly talk about. So if we were ever solving, say, inverse sine hyperbolic y equal to x for some number that you know x. Now what you could do is you could take inverse sine and you'd get y equals this, but you'd have to bring back in a minus. That minus is ignored when you're finding the inverse function to make it 1 to 1, but when you actually derive it using exponentials, it is very much there, and it will be a solution to this equation. The same thing is true for inverse cosh. If you're solving cosh y equals x, you'll actually get a plus or a minus here. However, for tan, in the process of constructing the inverse, we did get a plus or minus, but we rejected it, not because it was for the principal value to make it a one-to-one function, but just because it was a non-physical solution. We just saw that the right-hand side cannot be negative for real numbers, because the left-hand side is always greater than 0. So in our case, we don't get a plus or minus here. It's just something to be careful about. I've realized that I've got away with it. I took inverse tan. I just didn't think about the consequences. In this case, we're fine because you don't get a plus or minus. So if you're solving tan hyperbolic y equals x, just like we are here, really, so that sort of form, then you just get y equals this, no plus or minuses. So we got our two solutions. We just rejected this one this time because of the domain and the range, that kind of argument. So all right, I hope that clarifies things a bit.